The ground beneath the Great Lakes just sent a signal no one expected. Now, scientists say ancient faults are stirring again, raising new questions about how stable this region really is.
Tonight, this season's first big chill is in the air. Freeze alerts and warnings are in effect for more than 70 million people. Today, a near whiteout here in Wisconsin and near blizzard conditions are forecast in Chicago.
The seemingly tranquil expanse of North America conceals a restless reality just beneath its surface. A reality now laid bare by seismic rumblings and scientific revelations that few expected. The ground beneath our feet, long considered steady, has begun to tremble anew. In late October 2025, alarm bells echoed through geology labs across the globe. The Pacific Plate had jolted, twisting abruptly along concealed fault lines, sending shockwaves through continents and scientific minds alike. This was no isolated incident. The Pacific Rim was only the origin. Tectonic unease radiated inland, extending through the continent's heartland and into the deep basins that hold the Great Lakes. Those blue giants we thought we understood so well. Teams of scientists, drawing on seismic data and sediment cores, found not only indisputable evidence of Earth's persistent energy, but also a puzzle that upends our oldest geological certainties. The Great Lakes, carved, we believed, by slow glaciers, now appear to have an origin story more complex, perhaps involving drama and upheaval. As the Pacific Plate grinds forward, scientists are recalibrating the codes of earthquake detection and disaster forecasting. From tremors in the Midwest to fresh questions about the origins of Lake Erie, Michigan, and Superior, the implications are staggering. Is our planet's surface entering a new era of instability? Could the ground beneath cities, farms, forests, and lakes be on the cusp of transformation on a scale few living today can recall? Tonight, we venture into these depths, where tectonic plates grind and buckle, where infrastructure is tested, and where the Great Lakes themselves may be revealing secrets, new and old. How much of our geological past and how much of our future has lain hidden until now? Chapter 1. Ring of Fire, Chain Reaction. It began far from the Great Lakes, on another continent's edge. The Pacific Plate, so vast it sculpts the very boundaries of continents, has always been a region of heat and unpredictability. For centuries, its so-called Ring of Fire has simmered and erupted, generating earthquakes and volcanoes from the mountains of the Northwest to the trenches of the Pacific Ocean. But what unfolded on October 25, 2025, shook assumptions well beyond local borders. Seismic sensors in the Pacific Northwest, always alert for tectonic unrest, registered something never seen before in real time: a subduction zone, one of Earth's engines for creating and recycling crust, actively breaking apart. Faults ruptured, crust buckled, and a vast segment of the Pacific Plate slipped, driving rock downward with breathtaking might. Instantly, earthquake alerts blared throughout the region. Geologists soon realized the effects would not be confined to the Northwest. Across the vast Pacific Rim, volcano warnings were issued, with seismic stations from Alaska to Japan detecting flickers of renewed tectonic activity. The fear of cascading events, aftershocks, possible tsunamis, volcanoes stirring, spread quickly through scientific communities. This was no average earthquake. It was a powerful reminder that Earth's surface is alive and that stability can, at times, prove illusory. As data poured in, a new and unexpected observation emerged. Something within the North American continent itself was stirring. Ancient fault lines, some virtually untouched since the era of fur trapping and farmsteading, began to show activity. From Seattle to Cincinnati, a current of unease threaded eastward. Could the tremors from the Pacific Plate really reach as far as the Great Lakes? If so, what transformations might unfold in North America's greatest freshwater system? Chapter 2. New Madrid wakes up again. While the Pacific Plate dominated headlines, the center of the continent harbored its own shadowy unrest. Stretching from Missouri through Arkansas and into the Ohio Valley, the New Madrid Fault is an ancient geological scar, long dormant, but never far from memory. Historians remember the winter of 1811 to 1812. Then, a series of powerful quakes shook what was then frontier wilderness. The land heaved, riverbanks eroded, and towns were rattled. It was the largest seismic event ever recorded in North America, shaking the Mississippi and, reportedly, briefly reversing its course. In August 2025, seismic monitors indicated fresh tension in these ancient rocks. Small tremors pulsed subtly through the ground, mostly beneath notice, but ominous in their cumulative effect. Some of these events hinted at movement on or near the surface. Others rumbled deep within ancient fractures, flexing with new energy. The relationship between distant forces is complex. The arrangement of plates and faults is like weather in solid stone. But this year, lines of cause and effect appeared to overlap. Seismologists detected slow, rolling waves originating from the Pacific, as if October's massive plate shift had set vibrations echoing across the continent. For those living near the New Madrid Fault, uncertainty is palpable. Structures built on ancient river sediment and infrastructure that extends for hundreds of miles must confront the risks of renewed seismicity. If the disasters of the past returned, not in isolation, but alongside intense activity elsewhere, the impact could be profound. And each tremor that rattles the earth prompts new questions. What risks do people living near the edges of the Great Lakes face, given they are connected by the very bones of the continent to these distant ancient forces? Chapter 3. Did Quakes carve the Great Lakes? For generations, the story of the Great Lakes seemed clear. Glaciers, those titanic rivers of ice, scraped and gouged their way across the land. As the ice retreated, it left behind deep, water-filled basins: Erie, Huron, Michigan, Superior, Ontario. Their story was treated as settled fact, their beauty and grandeur fixtures of the landscape. Now, the ground whispers new possibilities. As the Pacific Plate moves and old faults awaken, scientists have returned to the Great Lakes with renewed urgency. What they are discovering is shaking one of geology's longest-held beliefs. Recent studies, including a 2025 study led by researchers at the University of Houston, are reconsidering the origins of these monumental lakes. For decades, their age and method of formation seemed decided. Yet, as scientists analyzed sediment samples and examined subtle structural patterns, a more intricate theory began to emerge. While glaciers played an outsized role, pre-existing tectonic activity may have shaped the land long before those ancient ice sheets arrived. Some clues point to fractured patterns at the bottom of each lake, hinting at ancient rift valleys or faults hidden since deep prehistory. Now, with major tectonic shifts nudging faults and fissures across North America, the lakes themselves may be responding. Researchers have observed changes in the intensity of cold spells within the lakes, supported by long-term measurement. In Lake Michigan and Lake Superior, strange shifts in cold events that seem, at times, to match up with subtle tectonic movements have been documented. A phenomenon echoed in Lake Erie and Lake Ontario. The timings loosely align with periods of increased regional seismic activity, though direct causation remains a subject of investigation. Could some cataclysmic earthquakes in the distant past have created depressions that glaciers later enlarged and filled? If so, The lakes are not just relics of frozen time, but reminders that North America's surface has been reshaped by powerful tectonic events. The prospect raises new questions. Might the next great shift in the Pacific Plate or the new Madrid zone again reshape the lakes, or reveal risks not yet imagined? Chapter 4: Hidden Faults, Hidden Disasters. For many, tectonic shifts seem the stuff of ancient history, too slow to matter in daily life. But the events of 2025 have forced communities, industries, and scientists to confront these risks as immediate and personal threats. Chief among concerns is infrastructure safety. Highways, railroads, bridges, and power lines blanket the Midwest and Great Lakes regions. This lattice work of civilization often sits atop ancient sediments, soils that can liquefy during earthquakes, undermining foundational strength. Seismic safety codes in parts of the Midwest and Great Lakes are not always robust. Designed largely in eras when the risk was thought remote, the threat is both immediate and insidious. Sudden structural collapse or slow, hidden damage as subtle shifts stress aging infrastructure. Beneath these visible networks lies another hazard. The Great Lakes region hosts numerous chemical plants and industrial facilities, some of which date to a less regulated age. Toxic spills following seismic shocks could have catastrophic consequences for water supplies and public health. Researchers caution about the potential risk of gas releases. In certain regions beneath the lakes, ancient geology has trapped pockets of methane and other gases. Seismic disturbance could, in theory, release these gases, though direct evidence for large, sudden releases is limited. Nevertheless, the risks of gradual emissions or minor releases, dangerous for aquatic ecosystems and possibly local populations, cannot be dismissed. While the probabilities of large-scale disasters remain under study, the events of 2025 make clear that vigilance is required. Catastrophe may occur in moments, with a sudden quake, or unfold over time, as infrastructure and ecosystems struggle to recover. Consequently, scientists and engineers urge proactive steps, updating building codes, monitoring chemical storage, and preparing for a wider range of seismic risk in regions like the Midwest and the Great Lakes. The new reality is that hazards once considered remote now demand closer attention. Chapter 5: When the lakes start sending signals. The Great Lakes often seem steadfast, a calm presence reflecting both sky and time, enduring winter and summer alike. Yet scientific measurements offer a different view, one of subtle dynamism and constant change, where water, ice, and air reveal the influence of the shifting earth beneath. Over recent decades, researchers have traced marked changes in cold spell intensities in all the major lakes. Notably, Lakes Erie and Ontario saw sudden cold events in the late 1970s, with comparable shifts in Lake Michigan in the early 1990s, and similar timing in Lake Superior and Huron a few years later. The cold spell's timing aligns in part with broader climatic shifts, but may also connect, through complex mechanisms, to tectonic processes operating well out of sight. One hypothesis now under investigation proposes that the lake's deep structure, possibly laid down by ancient rifting and tectonic faulting, makes them sensitive to shifts in regional geology. When distant plates like the Pacific shift, subtle tremors may travel through bedrock, influencing conditions below each lake. Researchers are employing advanced sensors, satellite monitoring, and water chemistry analysis to explore these connections. While the evidence is not yet conclusive, the data suggests that the Great Lakes are not passive, but instead finely attuned components of a living system. Every tremor, every deep groan, may ripple through water and currents, impacting ecological cycles, fisheries, and even the region's distinctive weather. If tectonic activity continues to increase, or if a major quake were to strike directly beneath the region, the lakes themselves might display dramatic changes, tumultuous mixing, altered stratification, or sudden changes in nutrient cycling. While these shifts are generally subtle and rarely catastrophic, the events of 2025 have reminded scientists and citizens alike of the interconnectedness of water and earth, of geology and climate.
Chapter 6. Ancient quakes still shaping today.
As modern seismic events unfold, the land around the Great Lakes stands as testimony to ancient catastrophe. Hundreds of millions of years ago, supercontinents fractured, volcanic chains erupted, and vast depressions opened, scarring the land and forming the rifts and uplifts visible in today's rocks. Current research suggests that the earliest origins of the Great Lakes could be linked to these tectonic events. Faulting and rifting, sometimes gradual, sometimes rapid, created the depressions and fractures that glaciers later exploited. When ice sheets arrived, their weight and movement deepened existing valleys and created new ones, laying the template for today's lakes. Sedimentary layers at the bottom of the Great Lakes point to periods of rapid change. Coarse gravels, deposits from ancient flood events, and layers twisted by seismic jostling all mark times when the land was anything but still. Recent paleoseismic studies have explored evidence of large ancient earthquakes, raising the possibility that major faults beneath the region could reactivate under new tectonic stress. Even in the last 50 years, marked shifts have occurred. The abrupt drops in cold spell intensity in the lakes in the 1970s and 1990s could be signals of atmospheric patterns, but as geological and climatological records continue to be compared, connections to deeper, older forces beneath the Earth are an ongoing topic of study. In the wake of 2025's events, communities are reviewing local risks. Wildfires triggered by damaged pipelines, chemical spills from ruptured tanks, changes in drinking water chemistry, and the enduring legacy of ancient violence. These dangers, while not inevitable, are plausible and demand careful preparation.
Chapter 7.
Living on a silent fault line. What does it mean to live in a place where the very Earth is in flux? As scientists redouble their efforts to model seismic scenarios, residents of the Great Lakes must prepare for risks now believed to be more than hypothetical. Preparedness, once the domain of those west of the Rockies, must now become standard throughout the heartland. Earthquake drills, emergency kits, and evacuation plans are prudent measures for communities from Chicago to Cleveland, Duluth to Detroit. Critical infrastructure, farms, laboratories, transportation corridors, depends on the underlying assumption of a stable landscape. Yet with seismic risks on the rise, the probability of gradual or disruptive change is growing. So, what should communities do to adapt? Planners and engineers are working with scientists to identify vulnerable bridges, water mains, and energy systems. Old maps are being revisited, hazard zones re-evaluated in light of new data. For many, the familiar outlines of the region, its coastline, its roads, even the lakes themselves, now carry a degree of uncertainty that is both unsettling and galvanizing. Wildfires sparked by damaged gas lines or electrical problems could become more common in the wake of seismic activity. Chemical leaks, though rare, can devastate towns and ecosystems. Shifts in water chemistry, driven by changes in subsurface geology, could require swift adaptation in how cities draw and treat their water. Research teams working across borders and disciplines are employing state-of-the-art technology to track changes in real time. Satellites chart land movement and deformation, while seismic arrays stand ready to detect any rumble or shift. The work is ongoing, rooted not in panic, but in realism and the hard lessons of history. Is this the last quiet moment before further changes? Or can new foresight and cooperation create resilience superior to any that came before?
Chapter 8. The next big shift is unknown.
The unprecedented revelations of this year have surfaced questions as profound as the forces that shape the Earth. The Pacific Plate's recent motion, for the first time observed with such clarity, has underscored a remarkable unity of geological destiny between distant coastlines and the Great Lakes' gleaming shores. Subduction zones break, ancient faults awaken. New studies challenge traditional narratives of slow, glacial shaping by adding the signature of tectonic influence and occasional cataclysm. With every new discovery, the idea of geological stability slips further away. From sediment cores that reveal layers of old disaster, to temperature shifts that may reflect seismic energy beneath the lakes, the interconnectedness of these colossal natural systems grows clearer. But for all the warnings, a quake here, a shudder there, gas and water swirling in unison, one thing remains: our relentless curiosity, the drive to understand, to look deeper, and to prepare for whatever comes. Will the next great plate movement occur within our lifetimes? Are our cities and industries, our farms and traditions truly prepared? Or do the lakes themselves, ancient and enigmatic, hold secrets yet unrevealed? Risks and wonders that might shape the next chapter in North America's story. As the earth stirs and the lakes mirror the sky, the story continues to evolve. Our home is an ever-changing tapestry. The forces beneath us signal their presence, calling for awareness, discovery, and awe. Which findings shook you most? What questions keep you up at night, knowing now that even the ground can change? How much of the familiar world will endure, and how much waits in silence, ready to astonish? Share your thoughts, your fears, your hopes, and join us as we look deeper, each day, into the mysteries of the world. One tremor, one question, one discovery at a time.